So on the screen is basically, for this part of the course, we're going through a number of example queries. These are representative examples, I think, where if you're comfortable with them, other queries will be either identical or similar, or you'll know all of what you need to be able to actually accomplish it. They get sort of progressively harder, maybe, I don't know, and yeah, that's where we're at now. We're just going through different queries using relational algebra, and that's it. So there's like 8 altogether that I want to get through. We've already covered 3 of them. So let's see. I don't want to go through all of them one by one again, but maybe I can just pause and ask if there's any questions about the ones that we've already gone through. So for example, this one, find all restaurants frequented by at least one person under the age of 18. We do a cross product between person and frequents. This way we have the names of people and the restaurants that they frequent and their ages are all relevant. So if you cross multiply them, you get all of the relevant information in each column. And then the cross multiplication is also going to be doing all possible pairings. So the number of rows are going to be many in this. And you want to keep only those rows where the names match. That is, that the name that exists in the person table also exists in the frequents table. So that's part of what the select is doing. The select is also only keeping those rows where the person's age is appropriate. And at the very end, we do a projection to only return the restaurant names because we don't care about the other stuff. We don't need to know the names or the ages. We just want to know the restaurant names. So, yeah. Are there any questions about, I mean, especially the sort of basic vocabulary, like the operators you should be comfortable with now? Not seeing any questions. I'll move on to the second one. Finding all the names of females who eat either yogurt or salad or both. This is very similar to the other query. It's just we're adding in the fact that you can have and or operators as a part of the predicate for the select. This is our third example. Yeah, this one was kind of interesting because there's more than one way to do it. And again, so long you don't use a join statement, anything can get full credit. The hard part here about finding the names who eat both yogurt and salad is, well, there's the option 2. You can just keep cross multiplying. And that will work. Yeah, that'll probably work on any query, actually, for things like this. You could just keep cross-multiplying and cross-multiplying and get a big, gigantic table with all of the information that you want, and then just do a select and a project. There's another option where you can incorporate the set intersection, where one query finds people who fit all of the conditions and they eat yogurt. Then you do another query that returns the same uh, the same type of relation under the same type of conditions, except for the fact that the food has changed. And then you look at where these intersect. And for anybody who are yogurt eaters and they're salad eaters, then they'll be members of the intersection. So both of these two queries will return the same thing. Yeah, the first one might be a little bit more efficient, but that doesn't matter as much. Okay, no questions?
Hi, Professor. Can
Yeah.
you hear me?
Uh-huh.
Okay. So I just have, can we review how would this play out, like step by step, for example, for like option one? Um, I'm a little bit unclear still how to use like certain operations.
Okay, so we can go through it step by step. We could go through each of them step by step, and then you could see that the result is the same. But maybe you can say something more about the last thing you said, that some of the operations you're not too clear about. Are there particular ones?
For example, so do you have to go, so this is like PEMDAS type of thing. You have to go the most inner parentheses. Or do you look at it from like an outside, like go from name?
No, I see. Yeah, no, this works just like regular algebra would. So a function can take an argument. So for example here, with the, oh, sorry, get a different color. Here, each of these, like the row, so that's a function. This select is a function, and this project is a function. Also, this intersection is a function. But focusing on these other ones, the row function takes a relation, and this will be evaluated first. Yeah, just like regular algebra. So it goes from the inside parentheses out. So after that's been evaluated, then this cross multiplication, which takes two arguments, A cross B. Here, person is A, B is a renamed eats. After that is computed, then the select eliminates certain rows, then the project is applied lastly. Similarly, the same thing is going to happen here. So one thing is the types are going to be changing. At the end of the day, this one at the top is going to be a relation with a single column named name, and that's it. So although, especially here during the cross multiplication, that table is going to have a person column, an age column, a gender column, another name column, and a food column. So that relation is going to have 5 different columns with a ton of rows. The select will reduce the number of rows, but not the number of columns. The project will reduce the number of columns down to just the name. So instead of having name, age, gender, name, food, it will just have a single name column. So similarly, this relation down here, or the second part of the query, is also going to return a relation with a single column, again, that column being name. And these both have to be done first. So this sort of, the yellow query and the blue query, they each have to be done first before the intersection. because the intersection requires the relations to have the same types. In this case, they're columns, the number, name, and types of their columns. So each of these two relations, the yellow and the blue, will have one column, both with the same name and of the same type, presumably a string. And that's sort of the order that this would go in. Does that answer your question, or should
Yeah,
I go more into it?
no, that answered my question. Thank you. I was just a little bit confused because, like, I guess I should have reviewed it a little bit more, but I was like, okay, so what does all this, all these mean? But thank you.
Sure, yeah. This is so I mean, I'm giving, let's see. For these, I mean, you don't have to have these actual values in these relations, okay? The form of the query deals just with the schema. So the schema is, are these things here. The schema. So relational algebra, you only need to know the schemas. You don't actually need to know any of the specifics, any of the, these things that I'm circling in red. You don't need to know those in order to be able to write the query. But it can be useful to try to go through it and have some small concrete example and write down everything. Maybe I'll do that in class, but I think that this is probably the best way for you to learn. So I don't want to do it for every query, but I think I did it here. No, not exactly. Here, yeah, for the first example. So here's the multiplication and the rename. So creating, writing down the actual result of that cross multiplication. Then the select, and that's these red lines of either of crossing them out, and then finally a project returns just the restaurant name. That's a good exercise for you to go through with small examples that you can do on paper. Of course, the actual queries when these happen, I mean, these tables can be just gigantic. And it's not something that you'd be able to do on by hand. But for the purposes of these queries, again, each of these are supposed to be illustrative of things that you would run into. These are like different scenarios and how to respond to them. Okay. Any other questions? No? Okay. Then let's continue. Okay. And again, I hope that this isn't repetitive for you. But, here, there's a couple ways I could do it. I could say the query, give the answer, and then just sort of move on. I really think that, some of you might be able to come up with a query yourself, which is great. But even the struggle and not being able to do it, I think, is helpful. So, Yeah, for these, I'll give you a few minutes um, to try it yourself. And even if you're getting stuck, that's okay. That means that you have things to pay attention to, or gaps in your knowledge, or um, um, there's a piece that you're missing that will make things click when you hear it, whatever. So please do actually try to sit down and write these queries to the best you can, and then we'll go over it together. So for this, I'll give you uh, 4 minutes. Okay, so 10:45. We'll come back. Sorry, I see I might have missed some questions. None of the females in the frequency table are the same as in the persons table. Would we assume that they are in making the query? Yes, right. Yeah, you can still make the query. In fact, I'll just do this. Yeah, the query could return no results, right? Maybe there aren't restaurants that are frequented by only females. That could be. Yeah, whether or not the query returns an empty result is separate from how to actually write the query. Do you guys need more time? Are you stuck on something specific? Do you have like a high level idea that you think will work? You're just not exactly sure how to phrase it? The only female part you're confused about. Um, I'm assuming not the English of it. I mean, you understand that part, but how to actually get this in a query. Okay. Good. Does anybody have any ideas for that? I'll give you a hint that it uses one of the operations that we haven't used yet. Oh, is somebody unmuting themselves?
I thought I had it, and then after that hint, I don't think I have it anymore.
Oh, well, maybe. Excuse me. Maybe there's more than one way to do it. So, yeah.
Well, mine had like project restaurants, and then in parentheses, wait, I forget what it's called. Like the sigma sign.
Oh, select.
Select, sorry, yeah, select gender equals female.
Okay.
And then from the cross table of person and frequency.
Select. I'm sorry. What was the?
So select gender equals female
Okay.
from the cross table of, or the cross product of person times frequency.
Of person times frequency. Like this?
Yeah.
Okay. A couple things. One, this cross multiplication is going to be easier if you add in a renaming of names, the name columns.
Okay.
But this will return restaurants that are frequented by at least one female.
Oh, okay. I think I misunderstood the only female part.
Yeah, because if there's males that go there, then we don't want those restaurants. And here there's no check for that.
Okay. Thank you.
Yeah. Okay. Yeah. But yeah, that's really good, and that's part of the answer actually. This that this is at least part of the answer that I don't know, I would come up with, I guess. Again, there might be different. Would we use a join on name? Oh, yes. So here this would also have and name equals name 2. So remember, with the combination of a project, a select, a cross multiplication, and a rename, that is a join. Okay, that's exactly what a join is. Could I explain again why this would not work? Sure. Let's see. Let's say there's John, who's 18 and male, as well as Amy, who's 23 and female. And John frequents Henry's, and Amy frequents Henry's. Okay, so this, okay, again, I'll kind of go inside out. This will create a relation with a name column, excuse me, a name column, an age column, a gender column, another name column, except this time we rename it to name 2, and a restaurant column. John, being 18 and male, would match with John at Henry's. John, who's an 18 male, would also be paired with, Amy at Henry's. Then we'd have Amy, who's 23 and female. She gets paired with John at Henry's. And Amy, who's 23 female, also gets paired with Amy at Henry's. Okay, so this part here is now that. Okay, that's what this equals. Each name only belongs to one restaurant. No. I mean, maybe John also eats at, or he also frequents, I don't know, Chipotle. Male. Once the tables are joined, would you delete any result that has gender equals male? No. So let's how to say, kind of, in a way. But let me finish up why this is problematic. Here, we would return, so now we have this select. So now I'm doing the select part. John is a male, so he's not female. This gets eliminated. Same thing here. John's a male, so that gets eliminated. Amy is a female, but the names don't equal each other, so that gets eliminated. And this row hits all of the right things. There's a female and the names match. Then we would return the restaurant. So we'd return this column, which would just have a single entry named Henry's. But you'll notice that John also eats at Henry's, and so this would be returning restaurants that have at least one female. Okay, so let me get rid of this. And I'll return a list of all the restaurants with gender equals males and delete all of the rows that are on that list. You might be able to do something like that. I mean, if you can come up with an actual query, I'd be happy to go through it. This restaurants that serve at least one female. Okay. Well, for the sake of time, one way to get this, and if you have another, jot down your idea and try to come up with another query. Because if I have like multiple correct answers here, that would be great, just for fun. But what we're going to do, these are restaurants frequented by at least one female. And these will be restaurants frequented by at least one male. Okay? This is what we want. So those restaurants that are frequented by at least one female, but that are not frequented by any males. So one thing you can do, if those are the restaurants that have only females, then, and maybe this is what the other person was getting at, I'm not exactly sure. Ooh, sorry, what? Copy that again. Okay. So this is the purple here. And I'll mark this in red. These are restaurants that serve at least one male. And then you do a set difference. Right, this, the set difference. And that's this. Okay, so this is how we get only females. This is part of what I mean by, having representative examples. This is a common type of query when you want to return things that only have something. But because of the nature of sets, these queries can end up looking more complicated. So it's equivalent to say the restaurants that are frequented by only females are those restaurants that are frequented by at least one female, which are also not frequented by at least one male. Those are saying the same things. The second one is a lot longer, it's a lot wordier, but we have to do it this way because we're dealing with this type of algebra. I mean, there isn't an only keyword. There, we have these 7 operators. That's it.
Hi, Professor. Just to clarify, should the rename function, should it be named to name to, or does it?
Yeah. Yes. Yeah. I mean, it can be renamed to anything, but yeah. Thank you.
Okay, thank you.
Mm-hmm. Why rename would make things easier? Right. So, let me go back to this example. The reason why renaming makes things easier is because this way you can still refer to columns by their name as opposed to their position. You could do everything according to its position. So the first column, the second column, the third column, you could is the first column equal to the fourth column? Or the first coordinate equal to the fourth coordinate? You could phrase things like that. You don't need a rename. The thing is, once you make that decision, everything afterwards has to be done using the coordinate numbers only, which means you have to keep track. If you start doing projects and things like this, then the columns are going to be maybe reordered. You're going to have more or less of them, and it can be a real pain to try to figure out the position, which, the number that the column is. But if you rename, then here we can differentiate these two columns. This is the name from frequency, and this is the name from person. So they're both names, but they're coming from kind of two separate places. And then we can have this check in the select. We can say that does an entry in this column equal an entry in this column? And we can refer to the columns by a string. In this case, name and name2. Instead of, you could say coordinate 1 equals coordinate 4, because the name column from person is the first column, and the fourth column are the names that are coming from the frequency relation. But although it might make the query look a little bit simpler, it will be very hard to maintain and know what's going on. So this is why the rename is used. Does the rename have an equal sign or an arrow? It's an arrow. Not that it really matters, but yeah, it's an arrow just by convention. If you do something small like that, using an equal sign instead of an arrow, who cares? That's a super small thing. Yeah, so here there's an arrow because you're changing one thing into another, so there's an arrow for it. With the equals, that is checking for if the values are actually equal. Okay, any other questions?
So how do we make this into one query that finds only females?
This does. This is one query. So
Is
this
like
relation,
okay.
set difference. I mean, this is all one query. This
Oh, I missed the minus sign. I'm sorry.
Yeah.
Okay.
Yeah, sorry. Yeah. So this entire thing is one query.
Okay.
Yeah. Sorry, I tried to bring attention to it using that. Yeah.
Professor, I have a quick question.
Mm-hmm.
So when you put name and name2, that eliminates any like name like any same name. I mean any different names. Like name 1 and name 2 have to be okay. Or that's
No,
just
it doesn't
renaming.
do that. So yeah, this here, that is just renaming the column, like the name of the column. And so instead of the column having name, it will be name2 instead, like here. So here, there's a column name. Here's a column name2. That's the only thing that the renaming does. Now, it doesn't, whether or not the name in this column is the same as the name in this column, that's what the select checks for. But before the select, I mean, this table is, this table here. I mean, that's a fine table. And there can be, here's a John and there's a Susan. Those names don't match. It's okay. They can exist. Even after this. Yeah, you can have John and Susan, John and name, Susan and name2, and that doesn't get eliminated. That just stays there. It's the select operation this part, the select, where it actually starts checking. And this John is not that Mary, so this goes away. John is not Susan. Here, John is John, so we keep that. Here, Peter's not Mary, Peter's not Susan, Peter's not John. That elimination is happening because of the select.
Oh, okay.
Yeah, the only thing that this is doing is this. It changes that column name to name 2. Okay. Maybe so it's not so messy. Okay. All right. Anything else? Uh-oh. Minimize that. Okay. Okay. This next one probably isn't as hard. I'm not sure. Whatever. Go here. Go to these again. Okay. Okay. Find restaurants that serve at least one pizza that John eats for less than $10. I'll give you the same, I don't know, 4 or 5 minutes. I'll try to look more at the chat window if you guys have any questions. But please do try to sit down and actually write down the query for this. For each of these. Okay, like I'm serious that this is like, I believe the way that people learn the best. So, okay, I'll check in with you guys in 4 or 5 minutes. Sure, I can insert example tuples. I'll reiterate that that's not necessary for the query. You only need to know, like, this is enough for the query. But sure, I don't mind adding some values. And Brown, I'm seeing, I guess maybe a potential answer, although that is more akin to a SQL query. Yeah, right now we're just doing relational algebra. Okay. I want to know, do you guys need more time? Are you stuck somewhere? Is it John eats as he already eaten, or can eat as and it's a possibility? Does this matter? I would say it doesn't really matter. It's some, I mean, like, maybe some people don't eat certain foods. If they're a vegetarian, if they're a vegan, or, religious observances or what have you. So, yeah, this is just, they've eaten it before, they're okay with eating. Is there anybody who thinks that they have an answer or something that they think is close? Otherwise, I'll just pick on somebody random. Work through it with you. Okay, then. How about Ryan?
Hi, Professor.
Hey, how are you?
Good, how are you?
It's okay. Okay, so what do you have something you're working with, or are you completely lost?
I think I have it.
Okay.
So I did the project restaurant, and then start parentheses, and then I have a lot of selects. I did
Okay.
select name equals name
Sorry.
2 equals name 3 equals John.
Name equals name 2 and what?
Equals name 3 equals John. And then I did food equals food 2 equals pizza.
Okay.
And then I did yeah, and then price is less than 10.
Okay.
And then I did open parentheses, person times rename name to name 2 of frequents, and then rename name to name 3 of eats, and then rename food to food 2 of serves.
Where is that another cross multiply?
Yeah.
Okay.
Oh, then I also had a restaurant renamed to restaurant 2, and then I finished that.
Oh wait. Oh, restaurant to restaurant 2. This is in the. Oh, sorry. This is in the same serves, restaurant to restaurant 2.
Yeah.
Okay.
And then close all the parentheses.
Okay. Okay. Let's take a look at this. Name equals John, food equals pizza. So this has almost all the constituent parts. It's a little more complicated than it needs to be, but this would work. Minus one thing that you have. Well, hold on. You're not using either of these renames. So you just rename it. And then, I mean, yeah, now that it's renamed, do you do anything with it?
Oh, I forgot to say I put those renames in my select.
Okay, so what is the select missing?
The food 2 equals pizza, and then
Oh, food 2 equals pizza.
yeah, and then restaurant equals restaurant 2.
Okay. Yeah, this would work. This would work. This is fine. Uh, uh,
Professor,
Yes.
don't you serves for price? Like the table serves, because that's the only table that has price.
Yeah, that's here. Oh, sorry, I just crossed it out. That is the table serves. We do have that.
Oh, you multiplied them by L4. Okay, I see.
Yeah, yeah. So this is taking all of the tables and putting them together into one really big, gigantic table. So it's taking the person table times frequents times eats times serves. So you have all of the information at your disposal. This could be a very large table, but sure, that's a valid query. It would work.
Just do eats serves.
Hmm?
Can you just use eats times serves?
That's an easier way to do it. How would that go?
Well, I did eats time. So I did production restaurant times select food equals food 2 equals pizza and name equals John and price is less than 10. And then then I multiplied eats times serves, and then I renamed food to food 2 and serves.
And sorry, could you say what your select was again?
It was food equals food 2 equals pizza. I don't know if I'm allowed to do that. I kind of made that up. Are you allowed to have 2 equal signs?
That it's fine. Yeah, I mean, I'll usually be a little bit more lengthy about it, but yeah, that's fine. I don't care.
And then I did and name equals John and price is less than 10.
Very good. Yeah. Yeah, yeah. So this, let's see, I'll do this as, yeah, both of these work. Okay. 1, 2. Yeah. So as far as the relevant queries here, we need to know that John eats pizza. So we'd get that from the eats column. Then we need to know which restaurants serve pizza and for how much. So here, these both serve pizza. And it doesn't matter if John goes there or not. That's not the question. It's not, that would be a different query. Which restaurants does John frequent that serve pizza less than $10? But this is just which restaurants serve pizza for less than $10 that John eats. So yeah, really just these two serves and eats. Yeah, this is the most economical type of query. You rename the food because that's the one that both of these relations share. John, that name is only going to appear one place. Yeah, and I think everything else is hopefully self-explanatory. So the second one, it certainly works. Yes, this will be, these will return equivalent things. It's just that the second query uses the person and the frequents table, and you don't really need them. Because we don't care about age, gender, or which restaurants John frequents. We just care about the restaurants that serve pizza. Okay. This is more economical. Okay, give you a minute. And any questions about this? No? Okay, let me take these.
Oh, wait, Professor.
Yes.
So it's not. Is the question? Is the query necessarily saying that it's that finding restaurants that serve at least one pizza that John can eat, or is it just? Is there like a distinction between John can eating or? And I'm still kind of like I understand the answer. I'm just kind of confused, like
Okay.
why we wouldn't include.
So maybe this is a little bit more indicative of how this might play out. Let's say John eats mushroom pizza, and let's see, Donato's will serve, I don't know. I mean, the serves, this is more of like a menu thing. Let me give myself a little more space here. Let's say that Donato's has a 3-cheese pizza for $15. And I'm trying to make it so it fits. Why is it doing it like that? That's weird. Okay. Oh, still don't get it. Whatever. Yeah, now maybe this is a mushroom pizza for $9, and at Donato's, I don't know, because they have nicer pizza. Oof. Whatever, something like this. So that is to say that maybe, yeah, sure, that John eats or can eat or is willing to eat. I don't know. Listen to noise. So, I mean, these could become more, I guess, quote unquote, realistic if you actually spent more time on them, or if you were certainly looking at real data. But yeah, maybe there's different types of pizza. And John, he only eats mushroom pizza because, I don't know, he's a vegetarian and he doesn't like just cheese pizza. Whatever. Food column equals pizza, or if it contains the word pizza. Ah, yes, I see here. Um, yeah, this is a good question. So really, this would be here, like food contains pizza instead of being equal to pizza. But yeah, I see. Yeah, if we do it like this, it would have to be contains. Yeah, I like it better the other way with just pizza instead of this. You could do this. That's just a more complicated query, and I'd rather not do that. Yeah, I want to keep these queries kind of a little bit independent of each other. Yeah, this one's supposed to be kind of a simpler query, actually. Yeah, I'll have to think about that, actually. If it's a query that you might want to use, for example, the word contains in. Yeah, you can do that. You can do that, actually. But it's, so you can do that in SQL, rather. But relational algebra, I don't know, maybe you could. Like food, I don't know, contains the word pizza. That's actually fine. Yeah, this is still a predicate. I'll go back. But, I mean, just because I don't want to make this too too lengthy, yes, you can do that, actually. This is fine. Contains pizza. Let me go back. See if I can. Okay, we'll keep it like this, the slightly more complicated one. So yes, you can do this. Food contains pizza. The string pizza. That would be fine. Although I probably won't be asking questions like this, but sure, just for the sake, because the question was asked. So yeah, do you need to distinguish between exact or contains? No, you don't. So in fact, I'll probably be. You know what? Actually, this is a good way to start going into quantitative reasoning. I think I mentioned this before. This, let me change this color here. The select operator, this thing, this is called a predicate. A predicate is a word that comes from logic. That means it's a statement that evaluates to true or false. And that's it. So long this can evaluate, you can apply it to a row, and the row can either be true relative to this statement or false relative to this statement. Excuse me, that's okay. This is something that you can capture in SQL as well, this idea of containing a string as opposed to being exactly equal to it. It is like a Boolean. Yeah, a predicate is a Boolean, except a Boolean can be, well, yeah, it's a Boolean. A predicate resolves to a Boolean, where Booleans are either true or false. Same thing with the predicate. Yeah. Let's see. Okay. Because we don't have that much class time left, instead of giving you another query, and I want to get into quantitative reasoning next time anyway, I might actually share something with you over Canvas to read that talks more in depth about this kind of thing, quantitative reasoning. But let me go into a new page here. Okay. Yeah, quantitative reasoning. Okay. Let me turn this off. And I'll go through, let's see. Okay, well, let's see. Here, a 1 will correspond to being true, and a 0 I'll use to correspond to false. Okay? Now, there's different operators. There's the and, the or, and the not operator. And if you have variables x1 and x2, x1 and x2, this is a truth table. So with two Boolean variables, x1 and x2, they can both take the value 0. One of them can take the value 0 while the other takes the value 1, or they can both take the value 1. Here, x1 and x2 are true only if both x1 and x2 are true. Right? So this uses, again, that operator. This is an or, and a not looks like that. I'm going kind of quickly through this because I'm pretty sure that you've seen this before. If you haven't, let me know, and I can slow down a little bit. But this is the same thing. These are just all of the possible values that two Boolean variables can take. And the or operator is true if either one of the variables is true. The not operator just flips. So it's applied to just a single variable, and it flips 0s to 1s and 1s to 0s. Okay. Now, for P and Q, two predicates, I'll remind you, predicate, this is a true or false statement. Okay, so for two predicates, this is a definition. De Morgan's law states, okay, so De Morgan's law is a way to distribute across predicates. So here, if we have two predicates, well, if you have two predicates and then you negate their and, this distributes in the way that not P gets applied to both P and Q. I'm sorry, the not operator gets applied to both the P and the Q, and it flips the and. So this becomes an or. So not P and Q is the same as not P or not Q. Both of these will result in the same, these are equivalent statements. Okay? If you're applying it to an or, it's a similar thing. Not P or Q is the same as not P and not Q. Okay, that's called De Morgan's law. So we're finished with class now. I'll pick it up from here the next time. But if you haven't heard of De Morgan's law, I encourage you to try to go through it and to come up with, a truth table to show that this is true. So here's P, Q. You can have P and Q, and then you can have not P and Q. And P's, that can be 0, 1, 1, 0, 0, 1, or 1, 1. This is 0, 0, 0, 1. Not P and Q would be 1, 1, 1, 0, and on. And then you try to show that these two are the same, or the other ones, whichever. That is a good practice for you. I encourage you to try that over the weekend, just with truth tables. And yeah, I'll see you next next week. Any more details about the term project? So the term project is going to be we're going to be starting it in a couple weeks. Yeah, so after quantitative reasoning, we have maybe one, hopefully one, maybe two more classes of this. So we'll definitely be done with relational algebra by the end of next week. SQL, we should be able to move a little bit faster, because really it will just be how do you take a query in relational algebra and write it in the SQL language. And that's a pretty easy transition. Yeah, and then once I start introducing the language of SQL, I will also start getting you guys talking more concretely about getting set up on Microsoft Azure, so that you can have a cloud system that you're using. So you'll have more details about the term project probably the week after next. We'll start doing that. Okay, I'm guessing you guys are just hanging out.